Okay, to solve this one, we'll take the log of both sides. So the natural log of 2 to the 9x plus 1 is equal to the natural log of 3 to the 5 minus 4x. Then we can use that property of logs that allows us to pull the powers down in front as coefficients. So we can write this now as 9x plus 1 times the natural log of 2 is equal to 5 minus 4x times the natural log of 3. I guess we'll distribute this through the parentheses, the natural log of 2 and the natural log of 3. And our equations become 9 times the natural log of 2 times x plus the natural log of 2 equals 5 times the natural log of 3 minus 4 times the natural log of 3 times x. So let's get all the x terms on the same side of the equal sign here by adding 4 ln of 3 times x to both sides. And that brings all the natural logs to the left, so let's get rid of the natural log of 2 by subtracting natural log of 2 from both sides. And the result is we end up with 9 times the natural log of 2 plus 4 times the natural log of 3. That's how many x's we have on the left. And on the right we have 5 natural log of 3 minus the natural log of 2. Now we could combine these logarithms into single numbers here by taking the 9 and putting it back up as an exponent of the 2 and the 4 an exponent of the 3. And the same on the other side of the equal sign. And then, well, leave that one. So this is equal to the natural log of 2 to the 9th plus the natural log of 3 to the 4th times x is equal to the natural log of 3 to the 5th minus the natural log of 2. And we can use the property of logs that the sum of two logs is the log of the product. So this is actually the log of 2 to the 9th times 3 to the 4th times x is equal to, this can be written as the quotient, the natural log of 3 to the 5th divided by 2. The difference of logs is the log of the quotient. And so finally, we're left with the answer to this. Some more room here. Let's go back up a little bit. So we end up with x equaling the natural log of 3 to the 5th divided by 2 divided by, well, we're going to divide both sides by the natural log of 2 to the 9th times 3 to the 4th here. Natural log of 2 to the 9th times 3 to the 4th. So natural log of 2 to the 9th times 3 to the 4th. So what does that equal? 3 to the 5th is 243. So this is 243 divided by 2. In the denominator, 2 to the 9th times 3 to the 4th is 41,472. So let's calculate this now and rounded off to the nearest millionth. So let's see, let me save the natural log of that while I've got it here. Okay, now 243 divided by 2 is 121.5, and the natural log of that is 4.7999 about, and so divide by the natural log of 41,000 there, and we get 0.4514265. 0 is the next digit, so rounding off to the nearest millionth is this place. And the next digit over is smaller than 5, so we can just truncate it there. And so this is our solution rounded off to the nearest millionth.